Rocking and rolling here.
All right.
Okay, so who are you? What's going on here?
All right. So my name is Holecek. Crazy name, I know. I'm Czech, and
All right.
I'm the director of development for Windows Shell. And it was we are kind of rolling off of Vista right now. We are just off of RC1 and just kind of collecting feedback and getting ready for RTM. And it's quite exciting because the feedback we are getting from our users and customers out there is mostly positive. Although we still see a lot of things which we can go and improve. But getting pretty close and very excited. The team is cranking, and I think that we are very close to getting done. And so you wanted to talk a little bit about what is Windows Shell and
what is it?
What is new in it. So it is quite a loaded question. I think that Windows Shell is a lot of things to a lot of people ultimately, and one of the challenges which we are facing in general on the Shell team is making sure that whatever features and decisions we are making are well thought out and really capture the need of our customer base. And so in Vista, we sort of looked at the Windows Shell from a multiple different points of view. Windows Shell is ultimately an application which runs on the top of the kernel and gets started as soon as the user logs in. And the Windows Shell team ultimately owns everything from the logon UI through the desktop, through the taskbar, through the start menu, through the Windows Explorer, common controls, which is a significant portion of the platform, which is being consumed by our developers, all the way to things like Windows management. And so when I think about the Windows Shell, there are ultimately two important aspects of it. So one of them is what I call the user's desktop. It is the part which everybody kind of sees right after they log into the machine. The start button, taskbar, task switching. In Windows Vista, we have added the sidebar control. Those are sort of the affordances, or those are the user interface pieces which are part of the shell. And the main focus of these affordances is around launching applications and managing running applications and managing tasks, and to some extent they create this user environment which the user owns and operates. The second and super important aspect of the Windows Shell is what most people know as Explorer exe, right?
Yeah.
It is the app which you launch when you are looking for a file, or when you are trying to find something, or again launch an application or whatnot. Mm-hmm. And so those are sort of the two big areas where the Shell team has been investing for Windows Vista, and we spend a lot of our effort. So if I would start to sort of think about what are the big improvements to the Windows Shell for Vista, I would start probably on the Explorer side, just because there's some super exciting stuff. Many people remember in 2003 we went to PDC and we announced WinFS and all kinds of awesome scenarios which we can do on the top of the file system, database-based file system. Mm-hmm. And many people also know that later on we decided that due to a lot of technical problems, WinFS is not feasible for Vista, and we need to reconsider what we want to do there. The Windows Shell team certainly did not lose the appetite for the user scenarios which WinFS invented and presented and led us to ponder. And so ultimately we decided that it is important, in order for us to innovate and push the envelope, it is important that we keep the pressure on and sort of deliver on the user scenarios which we had dreamed up then. Mm-hmm. And the main thing which we have done is already in Windows XP we have shipped a component which was called Common Indexer, and the Common Indexer was a piece of machinery which people used for speeding up their searches. And what we have done is we actually made the indexer to be a central piece of the Windows Explorer. And the way how we went about it is that we ultimately implemented a new data store abstraction, which let us abstract not only the file system, but essentially arbitrary data sources. And the arbitrary data sources are, in this case, are represented by ultimately a database, which aggregates and collects information about all kinds of data on your hard disk or the data which is relevant to you. And the interesting thing is that this whole stack presented a lot of challenges in order for us to get it performant and sort of switch from the file-based view of the world, which the Windows Explorer had previously, into what we call now item-based view. So in the release of Vista, we are no more thinking about just files on your hard disk, but we are essentially being able to navigate and reason and examine all kinds of properties and additionally invoke commands on arbitrary items. And it is well demonstrated in Vista by the fact that we can, for example, operate on the top of contacts. So in Vista, you can navigate into a folder, quote unquote, which is all of your contacts, and you can examine their properties, and you can do all kinds of different actions on top of these items. Very significant type of item is, of course, mail, which, as we know, typically is not a file-based item. So the fact that we can actually present directly in the Windows shell, that we can present the user with all the information which is being also dealt with as an email, which is super important. If you think about the user scenario, let me sort of backtrack a little bit. But if you think about the user scenario where a lot of us get a lot of our documents as attachments to our email. And so when I think about documents and when I think about how do I find these things and how do I operate, I very, very rarely think about boundaries between email applications or Explorer or whatnot. Ultimately, I want to go and navigate some structure, some namespace, if you will, and I want to say, look, show me all the items which I got from my boss, or show me all the items which I got from my wife. And it doesn't matter if those things live on a hard disk or if they are part of some email message or whatnot. So the whole goal for us to merge the world between email and file system was super important, because people don't think about the data from the perspective of the source they get the data from. They think about the data as something that they want to act on and interact with. And so that was the whole big push on making sure that the Windows Explorer is a item-based, if you will, pipeline or infrastructure. And so the other thing, which of course went into this, is that the pure volume of the data which we have to deal with now in Vista is much larger, because previously people tend to organize their data into all kinds of folders, and when you sort of look at when you examine the folder structure of a typical hard disk, there's number of items in each folder. Let's say it's on the order of thousands. Now, because we can issue queries against databases, the number of items which we are looking at is hundreds of thousands of items, if not millions. So one of the big effort and one of the things which we are delivering essentially in Vista is that we have created pipeline which scales into these type of sizes and lets us operate over things which are orders of magnitude larger than what we could have done in previous releases of the operating system.
That's a very interesting point. So are you saying that unlike in XP, if I were to open up a folder that had 1 million items in it, it would take a super long time to load?
Yes.
Are you saying that that's no longer the case?
So we have improved our focus on performance on all kinds of basic good engineering practices was very, very high, and so absolutely we have focused on making sure that we have asynchronous way to access data independent of where they are. Are they in a database? Are they on a local hard disk? Are they somewhere on the network? We have focused on actually deferring and structuring the load of the data into the view. So as a step one, we load only the most basic information about each of the things which we are going to present, and then as a subsequent loads we proceed with loading thumbnails and loading other properties which we call long properties, which take long time to load and extract out of the items. But at all times the view is completely interactive. A lot of that is happening on a background thread, and a lot of that is absolutely interruptible by the user, so the user always feels in control. So it's not necessarily that we can factually do a lot of this stuff faster, although we have invested into that as well. But definitely there is a perceptual win when the user sits in front of the computer. The perceptual performance and the fact that the Explorer is not blocking is definitely a huge win for the user and pretty much for all of us using the operating system. So that is sort of the basis of. That is sort of the basis of what we have done. What we have done on the Explorer side. Of course, big challenge for us doing all of these pieces was around the most obvious things like security and performance, as I already mentioned, and just basic quality of the engineering. And in Vista, we have, particularly with the new indexing infrastructure, where there is essentially a system-level service which is rolling through your documents and opening them up and looking into each of the documents, what the documents contains, and creates an index of the documents and extracting all kinds of metadata. There is a potentially large surface for attacks. And so one of the things which we focused on was making sure that we minimize the surface. And we invented things like a process isolation, where a lot of the things which a lot of the indexing parts which are happening without the user knowing, essentially, which are happening in the background, are happening in a low privilege process. So the process really does not have a option to write into the hard drive, or does not have a option to write into the registry. It is very much restricted with respect to the rights it is allowed to do on the system. And even further, what is very cool about this is and hopefully that will never happen, but if one of the indexing operations actually causes a fault and it should crash, it's not going to bring down the operating system or Explorer, but it just brings down the host, which is constantly being monitored, and in the very moment the host goes down, it gets restarted, and the whole thing continues. So we have really focused on isolating operations which are ultimately high risk with respect to reliability or security into a separate process, lightweight processes which allow us to monitor and also limit the possibly negative impact on the system if something bad should go wrong. This is fairly pervasive. We have done it throughout the entire stack for Explorer. So, for example, if you look at things like our new thumbnail extraction and our cache for generating thumbnails, it is very similar concept. We took the thumbnail extracting code and put it essentially into a separate host, and the cache is being populated in a separate process for the very same reasons I have already described. If there should be a malicious content, or if there should be a content which causes some of the code which we have crash, at least it's not going to bring the entire Explorer down. And so those are investments which were absolutely non-trivial and help us harden the entire infrastructure going forward. So that's sort of from the Explorer infrastructure perspective. Of course, the impact of the user experience is huge. Like today, when you launch Vista, obviously, when you click on the Start menu, you see a text box, and the text box is extremely powerful. It is something which delivers on many different functionalities. The most obvious one is it does searching. It takes advantage of all the infrastructure which I have just described to let you type in a few letters of a document you are looking for, or a few letters of an application you are looking for, or a few letters of a control panel or task you are trying to engage in, and it presents you with the result, and you can start right from the Start menu. You can very quickly engage in the task you are trying to do. The next obvious thing where this infrastructure plays a significant role is that the control, which we call word wheel internally, is very pervasive. It is pretty much everywhere in the user interface. Every Explorer window has a has a word wheel, and it sort of demonstrates how flexible the architecture is. So not only that we can word wheel or search over documents, and not only that we now index and return results like email, and you can essentially populate the results and the index with all kinds of other data sources. But for example, things like control panels now are also searchable using the same infrastructure and helping us deliver on the consistent, predictable user experience. So everywhere you go, you have a familiar search or word wheel, as we call it. You can tap your query and return the set of results, and it's just that much easier to get your stuff done.
Absolutely.
And the whole idea there is, no matter what you are looking for, you should if you just remember one thing, then you will always find it. And generally it is. It appears to be very successful through our user testing and through the feedback we are getting through our beta programs and all the other programs which we have with respect to customer feedback. Mm-hmm. The other thing which I think that is worth of talking about is, again, related to this whole search platform and indexing platform, is that it is a platform which is built around one core principle, and that is we are trying to eliminate any data jails on the system, and that is super important.
Can you repeat that?
Data jail.
Data jail.
It is a term which we have came up with when we were sort of thinking about all the different user scenarios. And the way how we think about data jails is in the following way: it doesn't matter where the data lives. I always want to be able to access the data quite rapidly. So it doesn't matter if the data is in my picture application, it doesn't matter if the data is in my mailbox, it doesn't matter if the data is on my hard disk, it doesn't matter if the data is somewhere on a server. I want to have one affordance in the UI where I can type a search query into, and it will return the data back to me. Mm-hmm. And as we know, there are other solutions on the market which certainly allow you to do searches across various different data sets, but the important differentiating factor for the Windows shell is that we are trying to say that there is no data islands, there is no data jails. You can search across anything which you have ultimately access to. And the way how the best demonstration of this principle is that ultimately Open Dialog today has the same set of capabilities as the Start menu or the Explorer itself. So if I launch Adobe Photoshop as an example and bring up the Open Dialog, and I'm looking for a picture which I imported into the operating system and lives in the Windows image gallery, and I type in the search using my metadata or whatever I applied in the image gallery, the nice thing is that I will be able to retrieve it, which is very different than some of the systems which are today available on the market, where as long as I live in the suite of applications which given the vendor gives me, I'm okay, but as soon as I move outside, I lose all of the work I have done in order to construct data and metadata and provide more information. So that principle is very core to our philosophy about what the shell should be to the end user. Mm-hmm. The shell is about getting to everything which I should be able to get to all of my data, to all of my applications, and getting it into the shortest possible way and in the most predictable way.
Absolutely.
So that's sort of that was a long story about the simple thing which is called the Windows Explorer, or what people see as a relatively simple application which runs on the top of the operating system. So the other big huge investment, as I mentioned at the beginning, it was into the desktop, into the user's desktop. And the things which we focused the most on, of course, we created a completely new look for Windows Vista, and we think that it is a very sexy look. It is very functional. It delivers on a lot of the goals which the design team sort of started with. Like, again, one of the top tenets which we had with respect to the Aero user interface, the Aero theme for the user interface, was we want to make sure that the content is the thing which the user gets to focus on. The actual Windows UI should kind of fade into the background, so the area of focus is the data, is the thing I'm working with, and so that's what you will see when you sort of look at the Windows user interface now. And we used affordances like transparency and a blur and drop shadows to sort of make the user interface much more subtle and much more screaming and sort of drive the visual focus and the attention of the user to what is important on the screen, which is their content and their data. So undeniably, the Aero theme was super important investment, and we have done a lot of work in that space. Clearly, we took the whole common control platform and rethemed it, which as many of our developers know, we have a theme engine since Windows XP, but at the same time, a lot of the stuff which we were trying to do for Vista was very innovative and new. As an example of a very complicated task was that most of common controls today draw using GDI, and GDI does not support alpha. And of course, if you want to draw on the top of glass, which is the transparent look we call in Vista, if you want to draw on the top of glass, you have to pretty much generate and obey properly alpha channel. And so for us to make sure that the alpha channel is preserved and properly generated in all of the controls which are supposed to draw on glass was a very important investment into the platform going forward.
Excellent.
We have also created a whole bunch of new UI concepts. We have published. There were all kinds of articles published about inductive UI, and we have taken a stab at a lot of the control panel surface, implementing the inductive UI and making sure that that we bridge the complexity between the complexity of the appliance, which is getting more and more complex every year, and between sort of the user expectations and how the user navigates and how the user deals with the complexity, can deal with the complexity. And inductive UI and some of the concepts which we derived from web were super useful for us in doing this stuff. So again, the control panel surface is very much different. Probably one of the biggest investments in the desktop, undeniably, is the whole window management effort which we undertook. So, as people know, pretty much the new display stack for Windows Vista is completely hardware accelerated, and it gives us the capability of do a nice compositing and all kinds of new. We could introduce all kinds of new effects, which not only improve the look and feel of the operating system, but actually turn out to be quite functional. Mm-hmm. So one anecdote or one story which sort of underlines this principle is if you look at what happens when people minimize windows. Mm-hmm. We have discovered through our user testing that a lot of people don't understand the action of minimizing windows. They get the fact that when you click the minimize button and the window disappears and a small little button appears on the taskbar, it is not obvious to many users that that's what actually happened. There's a whole class of users who don't understand that transition. The fact that the new hardware accelerated pipeline allows us to actually animate the window from the current state to the taskbar actually provides a continuum which the user can follow through time and now connect the two endpoints of the action and understand that it's a transition and it's not an abrupt change. So actually through some of these affordances which we have gotten through the new stack and new driver model, we can actually significantly improve the user experience and make the user interface much more obvious.
Sure.
There are other things which kind of contribute to the sizzle. I think that most of our users at this point saw things which we call Flip 3D, which is essentially the new Windows switching affordance, which essentially takes advantage again of the 3D hardware and actually presents the Windows in a 3D space. We also have a thumbnailing API which we use internally for displaying all kinds of thumbnails actually on the taskbar, so you can much quicker navigate between all the different minimized applications just by using a visual cues instead of having to parse clipped text.
Now, one thing I've noticed in that solution that you come up with is you're actually so if I'm watching a video and on channel 9 and I minimize it and then I highlight the button, it's actually playing.
Yes, good catch. The whole pipeline is completely real time, and again, it sort of demonstrates the capability which we are opening with using the hardware acceleration, the hardware graphics acceleration. It demonstrates the opportunities which we have going forward. In Vista, we have tapped into sort of the if you will, into the first set of applications which are rather obvious and not surprising, but without giving away too much what's going to happen in the future, it is fairly obvious that this infrastructure is going to be leveraged much more going forward, and it is a very important stepping stone for us to move forward and deliver some really cool but mainly functional user scenarios.
Excellent. And now, one of the other things clearly that you guys have spent a lot of time on was security.
Yes.
And one of the new security features, quote unquote, a lot of users find it kind of annoying.
Yes.
Is the let's say something happens, a process is spawned, or something, and a command is made to do something that requires administrative privilege. You guys basically take a snapshot of the desktop and then change the amount of light, and then you pop up this thing that says, "Hey, are you sure you want to do this?" "Yeah, I'm sure I want to, install the software I'm trying to install." It's a good question because, if I was not logged on as an administrator, or if some process was trying to install itself somewhere, you guys would have caught that and let me know that something's going on. So in the end, I understand what you're trying to do. What I'm asking is what led to the decision of your implementation?
It's a very good question. So the feature you are talking about is user account control, and the whole Windows ecosystem we have. It is quite interesting. We have something which, as far as I know, no other operating system on the planet has, which is we have a huge asset in all of the software and applications which have been written for the last 15, 20 years of this operating system being around. And when I say 15, 20 years, I really do not exaggerate. We know for a fact that some of our users still run 16-bit applications in the days we have 64-bit processors, right? And so this legacy which we have, which we carry along, is a huge asset to the operating system, but it's also partially something which slows us down with our ability to move forward the way we want it. And part of the problem is that in the early Windows 95, as we all know, there was really no good security model. Although you could secure your machine with a password, there was no really there was no differentiation between administrators and regular users. And a lot of applications in those days were written in a way that they want to enable. Or let me actually take a step back. A lot of applications written in those days are still important applications which a lot of our users actually run. And so one thing which we are still kind of trying to work through is how do you take advantage of the modern architecture of the operating system, where security model is a very important aspect of it, and at the same time, how do you make sure that all of the applications which are on the market and people rely on and build on the top of, and in some instances are mission critical, how do you keep those applications running? And so the thing which we have done ultimately is we have introduced the user account control architecture, and that architecture essentially monitors processes which are being launched. And it turns out that through our customer research and through our user research group, we have learned that a lot of our users are still running as the administrators, and of course that is good because all of their applications keep running, but it's also bad because it opens them up to all kinds of attacks, and it's very hard to protect them against these kind of attacks. And so the architecture which we have implemented is ultimately architecture which enables us to help them decide or help them broker the decisions about things which need architecture administrative access in the time when the process or application actually figures out that it needs the administrative access.
And I would just interrupt you briefly, just to go back to when you're running as administrator, it doesn't necessarily open you up to attacks, but rather if you are attacked, it opens you up to getting really screwed.
That is exactly right. That is
I just wanted to make that clarification.
Yeah, that is exactly the right way to think about it.
Okay.
If the fact that somebody runs as an administrator does not mean that you are more or less vulnerable to the attacks, but if you are attacked, the consequences of the attack can be much larger.
Absolutely.
And so the problem with UAC, the user account control, is how do we figure out what is good application and what is a bad application? If the application is essentially written to our guidelines, which we are publishing for the last 5 to 10 years, ultimately the application should never see the elevation prompts because it typically does not need an administrative access to the machine. It should be able to achieve everything through just a user level access to the machine, and life is good. Of course, a lot of our developers, and it's certainly not their fault. Some of it is on us that we are not being prescriptive enough with respect to what the guidelines should look like. We don't have a good testing tools. But the bottom line is that we still have a lot of applications on the market which do require the administrative access. And for us to determine if it's good or bad is pretty much next to impossible. And so ultimately we are asking the user to help us evaluate the current condition, because the user is the most familiar with the action they are taking, and they are probably in the position the best to understand the consequences.
Understood, which brings up a good point, though. It actually begs the question, then if I'm doing the same operation, so when I make a request to do the same process that I was just asked yesterday, do you have to give it, I say yes or no to the prompt, why should I be prompted again?
That's a fantastic question.
Okay.
So the answer is relatively simple. I mean, there's all kinds of code tampering which can happen. Like, it is very hard for us to store or cache, if you will, any of these things in any secure way. As soon as we introduce cache, which will ultimately store like, this is okay for me to run without elevation, and this is not okay to run for me without elevation. As soon as there is a store, that store is going to become a source of attacks, like immediately from that point on.
Yeah.
So, and once somebody cracks that store, pretty much all bets are off again. So we opted. We definitely don't argue that the user experience is the best user experience, but we definitely opted on the side of being more secure and more conservative, and sort of giving the decision to the hands of the user, and hoping that the user is informed and understands what exactly they are doing to make the right decision. For us, that decision is very hard to make. Of course, we keep working on making this architecture better and more self-sustained, so the user actually sees less and less of these prompts. That's sort of one vector of mitigating the number of elevations one user has to deal with. And the other thing, of course, we expect from our developers is that they will go back to their applications and see what changes need to be made in their apps so the apps actually don't require elevations, because clearly nobody wants to produce an app which puts up an annoying dialogue which says, hey, do you want to let me run? Because it is just outright scary for the end user.
Sure.
And so you asked actually a good question about, why are we dimming the whole user desktop and what the whole user experience looks like there. And so a lot of motivation behind what we have done there is essentially we want to make the UI as little spoofable as possible. And so what that means is that we don't want to enable, for example, different button clickers. As we all know, there's all kinds of technologies which allow you to click buttons. We don't want these applications to sort of act on the behalf of the user. And so the goal was to really differentiate between the user interface, which is the security user interface the user needs to respond to, and any other user interface which other applications will put up.
Excellent. So I mean, basically what you're saying is what I'm looking at when I get a UAC prompt is not the desktop.
That is correct. It is quite strange. So essentially, what happens in the background is we go as far as switching a session. So ultimately, the prompt for your credentials or for you allowing to continue in execution of the software runs in a completely different session than the user session, and the thing you see is essentially a static image of the user desktop. The reason we chose to do the static image is that it provides much more. The experience is much more continuous. It is not as disruptive as if we would black out the screen altogether.
Sure.
And the whole idea there is that we want to make sure that the context which that dialogue is coming up, at least to some extent, stays preserved. And so the dimming the screen and presenting the dialogue sort of affords us exactly that.
Fantastic. Now, another thing that I've noticed with the Windows shell traditionally is that it's typically, and this is from a developer perspective, it's just sometimes damn hard to write a shell extension. And that's typically been the case.
Yes.
The documentation hasn't been great.
Yes.
The interfaces haven't been well defined.
Yes.
And I know you guys have done some work in Vista to handle this. And I know Raymond Chen, who works for you, is probably involved in helping make this
Yes,
better.
Raymond, fantastic guy, as we all know. It is undeniably, it is a problem. And, I will say, unfortunately, we did not get as far as we wanted in Vista. We have huge ambitions into how to simplify a lot of the programming interfaces of the shell. But we have definitely invested into making the APIs much cleaner, making the APIs much more well articulated. We have added all kinds of APIs to improve and provide more access to the shell. But there's still a lot of work which we are looking at in moving forward the API surface with respect to the data sources and with respect to the presentation platform of the Windows shell. And a lot of our efforts is going to be certainly much more prominent in our next releases.
Fantastic.
Yeah, very exciting stuff.
It is. And I mean, basically what we're doing, we're showing that the shell in Windows Vista is the next snapshot in the iteration of the shell as it evolves. Because the shell, of course, is evolving. If you look at 3.1, into the groundbreaking 95,
Yep.
Now we have an XP. It's also, I mean, people don't really realize how different of an operating system XP really was.
That's exactly right. And look, let me give you another example of stuff which we have done in the Windows shell, which I believe is quite new and exciting. So a couple of things happened. One, we really looked at the feedback we are getting from our customers with respect to the shape of our namespace. The shape of the namespace is essentially the graph structure which describes all the different folders which you can access from the Windows Explorer. And one of the things which became very obvious is that the nesting of the namespace is quite cumbersome in a few little places. Number one is words like documents and settings with the spaces in the names. It is way too long, spaces are present, it is hard to type, it is easy to make a typo. So we shrink that down to just users. We have separated very cleanly app data and user data. We have made pictures, music, videos, and all the folders which were children of my documents. We have made them peers of that folder, so you have much more shorter and manageable structure. So a lot of investments in just the namespace were done in the Windows Vista, which reflect a lot of the feedback we have received from our users. The other thing which I consider super important and super exciting is the work we have done in place sharing. The thing in Windows Vista, you can ultimately share in place any item or any file in your file system without having to copy it into public folders or setting ACLs in a cumbersome way. We have introduced a concept of roles for readers and writers, and it is very easy for one to now take a document anywhere on your hard disk, right-click on it, say share, and through a few clicks through a wizard, have that document shared with their coworkers or spouses or whatever the environment is. And things like that are fairly subtle, but they address some of the biggest issues which we constantly see being reported by our customers and users. And so, as you said, it is evolutionary stuff. Windows Vista is definitely evolutionary stuff with the Windows shell, but we have made quite a leap. It is not incremental. We have really took some of the biggest issues which we received feedback about from our users and customers, and we really thought about them really hard, and we believe that we address them in a quite innovative ways.
Absolutely. I mean, one of the things I've noticed as I've been running RC1 is I haven't had to manually run Explorer.exe yet.
Very good. Yeah.
Because a lot of times it would freeze up on me due to either something I was doing or something an application was doing. Nevertheless, it's always a bummer to have to Control-Alt-Delete,
of course,
run Explorer.exe to solve the problem.
And a huge amount of effort was spent on hardening Explorer and hardening the whole shell infrastructure.
Fantastic. Well, hey, I'm sure you have work to do. Got to keep Raymond busy.
Yeah.
And I appreciate you taking the time to chat with us today.
Pleasure on my side.
All
Thanks
right.
for stopping by.
Great to meet you.
Likewise.